In this lesson, we're going to learn about working with lines and finding the intercepts of those lines when graphed. But before that, we're going to look at standard form of an equation. Standard form simply means that the equation is written with the x and the y terms on the same side equal to the number. And typically we'll see that as ax plus by equals c, where a, b, and c are all just integer values, and a and b can't equal 0. So some examples of equations that are in standard form: 2x plus 5y equals 10, and we also have a negative 4x minus y equals 12. Some examples, so these two are in standard form because the x and the y values are on the same side equal to a number. Standard form, when it's not correctly written, the x and the y values are not on the same side, such as this example, 3x equals a negative 2y plus 5. We can rewrite this into standard form if we added 2y on both sides, but as it's written, this is not in standard form. Looking at our other equation, we have 1/2 x plus 6y equals 8 1/4. This one, even though x and y are on the same side, this one is not correctly written in standard form because of the fractions. Fractions aren't integer values, so we would have to translate this into integer values by multiplying through the denominators, and we'd be able to get it into correct standard form. So again, the standard form of the equations, a, b, and c are integers, meaning they can't be decimals or fractions, and x and y terms have to be on the same side, and the x term should be a positive number. In this lesson, on the quizzes, they want x to be positive, so you would just have to divide by a negative. If everything else looks correct, but the x value coefficient isn't positive, then you can divide each term by a -1. So an example of correctly writing something in standard form: if you were to add 2y on both sides, you would be able to move that 2y term to the other side to get 3x plus 2y equal to 5. And now this equation is correctly written in standard form. In this equation, we have to simplify first, and then we can write it in standard form. So to simplify, we would need to multiply through a 2 to get 14 plus 2 times x is 2x plus 2 times y is 2y equal to 7. And then we could subtract 14 from both sides to get 2x plus 2y equaling 7 minus 14, so a -7. Now this is correctly written in standard form. To write an equation that has fractions, if our equation was 3/4 x plus 6y equals 14, for example, this one, even though x and y are on the same side, it's not in standard form. You would need to clear this denominator to make it an integer value in order for it to be in standard form. So think about this as being 3 divided by 4. The opposite of dividing by 4 is to multiply by 4. So you could think of this as I'm multiplying every single term by 4. So then 4 times a 6y. And I actually want to group these around the 4. So 4 times 3/4 x plus 4 times 6y equals 4 times 14. And then what will happen now is 4 times 3/4, these are on opposite sides. You could think of this as 12/4, which would reduce to 3, or since they're on opposite sides of that fraction bar, you have 3x plus 4 times 6 is 24y equal to 4 times 14 would come out to be 56. So 4 times 14 is 56. Now this equation is correctly written in standard form. So again, to clear that denominator, multiply through by whatever that denominator value is. If you have more than one fraction with different denominators, you have to make sure you multiply by all of the different denominator values. So another part of this lesson is thinking about if graphs are collinear or not, if the lines are collinear. Collinear simply means when you graph those points, it forms a straight line. So if we were to graph the points 2, 1, 3, 3, and 4, 5, these 3 points form a straight line. I can connect them with a straight line, and it's easy to see that they are collinear. If they're not collinear, then these points are not going to form a straight line. So if I graph these points, 5, 1, 4, 2, and 0, 6, these points, if I try to connect them with a straight line, these ones also form a straight line, so they are collinear. An example of one that wouldn't be collinear would be if I had the point -2, 3 as one of my values. If I graph that point, -2, 3, that's over here. It's clearly not on this line, so these points would not be collinear. Finally, talking about intercepts of a line. The intercepts are just where that line is crossing your x or your y axis. So on my y-axis, I can see that this line crosses at this point here and then hits my x-axis at this point. So the coordinates then, this is the point 0, 5, and this is the point 3, 0. So from this graph, I would say my y-intercept is 5, meaning it's crossing my y-axis at 5, and my x-intercept is where it crosses my x-axis. I can see that it's crossing at 3, so this equals 3. But the coordinates are important to note because any point on my y-axis is going to have an x-coordinate of 0. Any point on my x-axis is going to have a y-coordinate of 0. Doesn't matter where these points are. Any of these other points on here, my y-coordinate is always going to be 0 if it's on my x-axis. And on my y-axis for my y-intercept, no matter where this point is, any of these points, my x-coordinate of those points is always 0. That's important because if you don't have a graph, you can use that information to find the x and the y-intercepts of that line. So I have an equation 5x minus 4y equals 20. I don't have it graphed, but I can still calculate out the x and the y-intercepts by plugging in 0 for one of the coordinates. So if I want my x-intercept, that means it's on my x-axis. I know from this that my y-coordinate is always 0 if it's on my x-axis. So I know y equals 0. So you can use the equation and plug in 0 for y and find that x-intercept. So -4 times 0 is 0. So we have 5x equals 20. And then divide by 5 to get x equals 4. This means my x-intercept is crossing my x-axis at 4. Now to find the y-intercept, I do the same thing, but this time I plug in 0 for x. So x equals 0. So 5 times 0 minus 4y equals 20. If this equals 0, I still have a minus 4y. Watch for this. This is a common mistake. A lot of times students will drop the negative, but that subtraction goes with the 4. So a negative 4y equals 20. Dividing by a negative 4 makes the equation y equals -5. So my y-intercept is at a -5, meaning it's crossing my y-axis at a -5. So then you can graph those points. If the y-intercept is at 4, and the x-intercept is at 4, and the y-intercept is at -5, I can graph those 2 points. And you just need 2 points to graph the equation of a line. There's the graph of that line. So one more quick example if we're finding the coordinates of our x and our y-intercepts. So again, for my x-intercept, I'm going to plug in 0 for y. So 3x minus 2 times 0 equals 18. Simplifies to 3x equals 18 and x equals 6. That means it's crossing my x-axis at the coordinate 6 for x. Now I'm doing the same thing for my y-intercept. 3 times 0 minus 2y equals 18. So 3 times 0 is 0, so I have a minus 2y equals 18. And dividing by negative 2 makes it y equals a negative 9. So on my y-axis at a negative 9, right there, now I can graph the line connecting those 2 points.